China has clearly invested in this defense industrial infrastructure to produce these ships.
Deep inside a desert where nobody bothers to look, China has built something that is giving America's most powerful warships a serious problem. Sounds crazy, but this is actually happening right now. Anyone can see on simple satellite images. What exactly did China build out there? And why does it matter so much? Join us as we uncover the secret hiding in the sand. The discovery right in the middle of a massive desert, surrounded by nothing but sand for hundreds of miles in every direction, sits a full-sized aircraft carrier. And we are not talking about a toy or a scale model or some kind of artistic installation. We are talking about a life-size, perfectly constructed replica of one of the most powerful warships ever built, just sitting there in the baking heat like it belongs. And here is where it gets interesting, because the mock-up is not based on any Chinese vessel. It is an incredibly detailed copy of an American ship, specifically the Gerald R. Ford-class carrier, which happens to be the most advanced aircraft carrier currently operated by the United States Navy. Every single feature is there. It has the flight deck layout, the island superstructure, the exact dimensions that make these ships instantly recognizable from above. And right next to it sits another replica that looks suspiciously like an Arleigh Burke-class destroyer, another cornerstone of American naval power, both of them parked in a desert where no ocean exists for thousands of miles. But here's the part that really blows your mind, because when analysts started digging deeper into the satellite imagery, they did not find just one site. They found multiple locations scattered across the desert, each one containing different configurations of these ship replicas. And the scale of what had been constructed across all of these locations was, and trust me on this, absolutely staggering. This was not some rushed construction job either. Satellite records show these sites evolved over several years, starting from simple outlines scratched into the desert floor and growing into fully realized three-dimensional replicas. Which means someone planned this carefully, managed it effectively, and saw it through from beginning to end. And that level of commitment alone tells you that whatever China is doing out there, it is something they consider very, very important. The Taklamakan Desert. So, let us talk about the place where all of this is happening, because the Taklamakan Desert in northwestern China is not your typical dry landscape with a few rocks and some dusty hills. This place is something else entirely. And once you understand what it is actually like out there, the decision to build a secret military testing ground right in the middle of it starts to make a lot more sense. Here is a number that puts things in perspective. The Taklamakan is the second largest sand desert on the entire planet, stretching across an area roughly the size of New Zealand. And it has been described, quite accurately, as one of the most inhospitable places on the surface of the Earth. The kind of place that does not forgive mistakes and does not welcome visitors. And the name itself makes that point better than any description could, because in the local language it roughly translates to, "Go in and you will not come out." The temperatures inside the desert swing to extremes that are genuinely difficult to wrap your head around. During the peak of summer, the ground can exceed 120 degrees Fahrenheit, hot enough to cause serious physical harm within a very short time, and then the same landscape drops to freezing temperatures when the sun goes down, or the seasons change. So whatever is being built and tested out there has to survive both ends of that extreme spectrum, which is an engineering challenge all by itself. And then there are the sandstorms, which sweep across the landscape with terrifying regularity and can appear with almost no warning, burying equipment, disrupting operations, and making any kind of outdoor work brutally difficult. These are not occasional inconveniences, but a defining feature of life in the Taklamakan, and they make everything harder. But here is the thing, and this is the part that reveals some genuinely smart strategic thinking. All of those qualities that make the Taklamakan so brutal and so difficult are exactly what make it so perfect for what China is doing there. It sits deep inside Chinese territory with no foreign borders nearby, no civilian populations at risk, no international shipping lanes passing through. More interestingly, there is no way for outside observers to simply walk in and see what is happening on the ground. It is essentially a natural fortress sealed off from the world by distance and geography. And that level of control and isolation is exactly what you want when you are testing weapons that could reshape the balance of global military power. The moving target rail system. So here is where the story takes a turn that nobody really saw coming, because running right through the middle of this desert testing site is a train track, and if that sounds strange on its own, just wait, because this is not a normal straight railroad line built to move people or cargo from one place to another. Instead, it twists and curves through the completely flat desert in ways that make absolutely no sense from a traditional engineering standpoint. And that is exactly what caught the attention of analysts who were studying the satellite imagery. Think about it from a logical perspective. There are no mountains to go around, no rivers to cross, no valleys to navigate. The terrain out there is flat in every direction. So building a winding serpentine track instead of a simple straight line would cost more, take longer, and serve no obvious transportation purpose. And yet, there it is, curving and bending through the sand like someone drew it freehand. And the reason why reveals something genuinely brilliant about what China has engineered out there. Those curves are not mistakes, and they are not random. When analysts mapped out the turning radius and the angles of each bend in the track, they discovered that every single curve corresponds precisely to the actual maneuvering capabilities of a real aircraft carrier. Because vessels that size cannot spin on a dime, they have very specific turning limitations based on their weight, their length, and their propulsion systems. And China has apparently done all of that math and then built it into the track itself. And here is what the track actually leads to, because at the end of all those carefully engineered curves sits another aircraft carrier mock-up. Except this one is different from the stationary replicas elsewhere on the site. This one is mounted on a movable platform that can slide along those rails, which means China has essentially built a full-scale moving target system right there in the desert, capable of simulating a 900-foot warship traveling at speed and making evasive combat maneuvers, all while weapon systems are being tested against it. The scale of what this represents from an engineering perspective is honestly hard to overstate. Imagine building the world's largest and most expensive shooting range, except the targets weigh thousands of tons, move on rails through the sand, and replicate the exact movement patterns of real naval vessels under combat conditions. And you start to get a sense of just how sophisticated and how committed this testing program really is. Because this level of detail does not happen by accident. It happens because someone thought very carefully about how to make the testing conditions as realistic as humanly possible, and then actually built it. The weapon being tested, the Dongfeng Funkwerks 21D. Now that you understand the testing ground, it is time to talk about what is actually being tested there. Because the weapon at the center of all of this is something that has been making defense analysts genuinely nervous for years, and once you understand how it works and what it is designed to do, you will see exactly why China has gone to such extraordinary lengths to build and refine it in that desert. The weapon is called the Dongfeng 21D, and it has picked up a nickname in military circles that tells you everything you need to know about its purpose. They call it the Carrier Killer, and it earns that name through a combination of speed, range, and technology that challenges everything the world thought it knew about how aircraft carriers could be defended. Because for decades, these ships have been considered almost untouchable when they travel with their full battle groups of escort vessels, submarines, and protective aircraft surrounding them. Here is how it works. The missile launches and climbs high into the atmosphere on a ballistic trajectory, traveling hundreds of miles while still gaining altitude, and then it comes screaming back down toward its target at speeds that are almost impossible to comprehend. We are talking about faster than Mach 10 during the final approach, which translates to over 7,000 miles per hour. Fast enough that the friction with the surrounding air creates a glowing plasma envelope around the warhead as it descends, like a tiny artificial meteor falling toward the ocean. But speed alone is not what makes this system revolutionary. Because plenty of missiles are fast, what makes the Dongfeng 21D genuinely different is that the warhead can actually steer itself during that final descent, using what engineers call a maneuverable re-entry vehicle, meaning it can make real-time course corrections mid-flight to track a target that is actively trying to move out of the way. So even if a carrier captain sees the threat coming and orders evasive maneuvers, the warhead adjusts its path to follow. The engineering challenges involved in making that work are genuinely mind-bending because you need guidance systems that can process information and execute course corrections, while experiencing temperatures of thousands of degrees and forces that would destroy most materials instantly. You need a warhead that remains controllable even while surrounded by superheated plasma. You need all of that to function reliably enough to actually hit a moving ship in the middle of the ocean. And those desert mock-ups on their winding rails are precisely where China tests and refines every single one of those incredibly demanding requirements: the satellite kill chain. Here is something that does not get nearly enough attention when people talk about these desert tests, because the Dongfeng 21D missile is impressive on its own, but the missile is actually only one piece of a much larger and much more sophisticated puzzle, and without the other pieces working perfectly around it, even the most advanced warhead in the world becomes a very expensive way to miss a target somewhere in the middle of the ocean. Think about the actual challenge from a technical perspective, because you need to first detect a ship somewhere within millions of square miles of open ocean. Then you need to track it continuously as it moves and changes course. Then you need to calculate its speed and heading, and predict with precision exactly where it will be by the time your missile arrives. And then you need to transmit all of that constantly updating information to a warhead that is traveling at hypersonic speeds through superheated plasma, all while the target ship is actively jamming your signals and launching electronic countermeasures designed specifically to confuse and defeat your guidance systems. That is an almost unimaginably complex chain of events that all have to work together perfectly, and China has apparently cracked it, because over the past 15 years, they have launched dozens of reconnaissance and surveillance satellites that now form a continuous monitoring network capable of watching vast stretches of ocean without interruption. And those satellites are connected to ground-based radar systems and over-the-horizon radar arrays that together create something analysts have started calling a kill chain, an integrated end-to-end system that links detection to tracking to guidance to impact in one seamless operation. But even that is not the whole story, because threading all of that hardware together still leaves an enormous data problem. The sheer volume of sensor information flowing through this system at any given moment is staggering, and somewhere inside all of that noise, you need algorithms smart enough to filter the useful signals from the useless ones, identify the real targets among potential decoys, and continuously update targeting data fast enough to stay ahead of a moving ship. And that is where artificial intelligence and machine learning come into the picture, because China has developed sophisticated software systems to do exactly that job. And the desert facilities are where all of it gets proven. Not just the missile, not just the satellite network, not just the algorithms, but the entire chain from the moment a target is detected to the moment the warhead arrives, running it all together under conditions as close to real combat as possible, validating every single link, finding the weak points, fixing them, and running the tests again. Which is why what is happening in that desert matters so much more than it might appear from a distance. Why the desert? Strategic reasoning. So you might be sitting there wondering why China would choose to do all of this testing in a desert instead of just sailing out into the ocean and running the tests there. And it is actually a really smart question, because the answer reveals two completely different layers of strategic thinking happening at the same time. One practical and one psychological, and both of them matter enormously to understanding what China is actually trying to accomplish. The practical layer is fairly straightforward when you think about it. The Taklamakan Desert is vast, completely isolated, and entirely under Chinese control, which means there are no commercial shipping lanes to worry about, no international waters that could create diplomatic complications, no civilian vessels that could accidentally end up in the wrong place at the wrong time, and no foreign observers who could simply show up and watch what is happening from a nearby hilltop. But here is the second layer, and this one is far more fascinating, because by conducting these tests in an open desert that is fully visible to satellites operated by the United States and every other major military power on Earth, China is not hiding anything. In fact, they are doing the complete opposite. They are putting their capabilities on display deliberately, and that choice is not accidental. It is a calculated move in a much larger strategic game that has everything to do with deterrence. In military strategy, sometimes the knowledge that a weapon exists changes the behavior of your opponents just as powerfully as actually using that weapon ever could. And China understands this perfectly. Because if every defense planner in Washington already knows that Beijing possesses a missile system capable of striking aircraft carriers from hundreds of miles away, that knowledge alone forces a change in how American naval commanders think about deploying their ships in the Pacific. The impact on American carrier operations is very real and very significant. Because the United States has traditionally relied on carrier battle groups to project overwhelming military power into any ocean on the planet, these floating cities of military capability can sail anywhere and bring enormous force to bear on almost any situation. But if those carriers now have to remain hundreds of miles further back to stay outside the range of land-based missiles, suddenly the aircraft they carry cannot reach their intended targets. China has essentially found a way to shrink the effective reach of American naval power without firing a single shot in anger, simply by demonstrating clearly and publicly that the capability to strike those carriers exists and works. And that is a genuinely innovative approach to shifting the strategic balance, one that costs a fraction of what building a competing carrier fleet would require. The bigger strategic picture. Step back for a moment and look at everything China has built in that desert. The mock-ups, the rail system, the moving targets, the satellite network, the algorithms, all of it. And what you are actually seeing is not just a weapons testing program. It is the physical expression of a military philosophy that is fundamentally different from the approach the United States has taken for the past several decades. And understanding that difference is the key to understanding why this all matters so much. The American approach to military dominance has traditionally been built on the idea of matching and exceeding every potential rival in raw capability. More carriers, more aircraft, more submarines, more of everything. And for a long time, that strategy worked extraordinarily well because no other nation on Earth had the economic resources or the industrial capacity to keep pace with that kind of military spending across every category simultaneously. China looked at that situation and made a very different calculation, because trying to build more aircraft carriers than the United States would take decades of effort and an almost unimaginable amount of money. And even then, there is no guarantee of catching up, so instead of competing directly on those terms, China asked a different question entirely, which was not how do we build more of what America has, but rather how do we make what America has stop working the way it is supposed to. That shift in thinking is what military strategists call an asymmetric approach, and it is genuinely smart, resource-efficient thinking that plays directly to China's existing strengths in missile technology and satellite systems rather than trying to build entirely new capabilities from scratch. And the desert testing facilities are the most visible and most dramatic expression of that philosophy in action anywhere in the world today. It is worth pointing out here that the United States does similar things. There are documented cases of American facilities in Nevada housing replicas of foreign military equipment, including Russian aircraft, and analysts have spotted copies of the Chinese J-20 stealth fighter at American test sites, so this kind of mirror testing is standard practice across modern military development. What makes China's program stand out is purely the scale and sophistication of what has been built. What is happening in that desert could influence the global strategic balance for decades to come. Because if anti-ship ballistic missiles prove consistently effective against moving targets under realistic combat conditions, it does not just change how China fights. It changes the fundamental assumptions about naval warfare that every military on Earth has operated under, since aircraft carriers first proved their dominance during the Second World War. And that is a genuinely historic shift in how human beings project military power across the oceans. The iterative development cycle China has built around these desert facilities also deserves serious recognition, because every successful test feeds data back into the guidance systems. Every impact measurement refines the warhead design. Every tracking simulation improves the satellite algorithms, and the result is a program that gets meaningfully better with each round of testing, rather than simply repeating the same experiments over and over without learning from them. So, there you have it, and when you pull all of it together, what started as a genuinely bizarre image of warships sitting in the middle of a desert turns out to be one of the most sophisticated and strategically significant military testing programs operating anywhere on the planet right now. And the fact that it took the world a little while to fully understand what it was looking at only makes the whole story more fascinating. Those full-scale mock-ups were never random constructions. They are precision instruments built with a very specific purpose, gathering real data about how anti-ship missiles perform against realistic targets that replicate the exact dimensions, radar signatures, and movement patterns of the vessels they are designed to destroy, and every impact crater left across those desert structures has made the system a little more refined and a little more dangerous. The moving rail system, the satellite kill chain, the artificial intelligence filtering sensor data in real time. All of these pieces connect into something much larger than any individual component. They form an integrated testing ecosystem built to validate an entirely new theory of naval warfare, one where the advantage belongs not to the nation with the most ships, but to the nation with the most precise long-range strike capability. China has combined innovative engineering, long-term strategic planning, and a deep understanding of its opponent's vulnerabilities into something that has genuinely changed the conversation about power in the Pacific. And doing all of it inside one of the harshest environments on Earth only makes the achievement more impressive. The open question that all of this leaves behind is whether missile technology will eventually make traditional naval power obsolete, or whether defensive systems will evolve fast enough to keep carriers relevant. And honestly, nobody has a definitive answer to that yet. But those ships in the desert suggest that someone is working very hard to find one. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.